Okay, so now that we know how to scale our application and have it behind a load balancer, let's look into some more fundamentals elements, such as Route 53, to make sure that people can access your application using a URL. But also, we're going to learn about how to store data. And for this, we'll do a deep dive into Amazon RDS and ElastiCache. At the end of this section, you'll be able to understand how to structure your application in what's called a 3-tier web app. Let's get started.
Now we are getting into the fundamental topic of Route 53. So Route 53 is a managed DNS, and DNS stands for Domain Name System. So what's a DNS? Well, DNS is basically going to be a collection of rules and records, and that help your clients, so your web browsers usually, to understand how to reach a server through URLs. And so in AWS, you have 4 most common records. You have the A record, that is a URL to IPv4. You have the quadruple A record for URL to IPv6. CNAME for URL to URL, and alias for URL to AWS resource. So you should know about these 4, just make a note of them, they're very important. So you may be asking, how does it work, a DNS? Like, I don't even see it. Well, because you don't see it, I'm going to show you a diagram. Here is my web browser, and I want to access my application server, but I don't know the IP of the application server. So I'm going to use Route 53, and I'm going to say, I want to go to myapp.mydomain.com. And Route 53 is aware of what that is. And it says, okay, it's an A record, so it's mapping a URL to an IP, and you're asking for myapp.mydomain.com, and I'll send you back the IP 32.45.67.85. And that's the IP you should use to reach your server. Now my web browser says, oh, that's cool, thanks. And it makes an HTTP request using the same domain name, but this time it knows to go directly to the application server, and the application server sends back the HTTP response. Now, because the DNS requests don't happen at every request, they get cached, so my web browser will know that now myapp.mydomain.com is my IP 32, etc., etc. And so basically my web browser now goes straight to my application server. So that's how it works for A record, but it works similarly for a quadruple A record, for a CNAME, or for an alias record. And so all these things don't have to be implemented by your web browser or anything. They just work out of the box. Every web browser knows how to work with the DNS. Okay, but this is how, at a high level, how Route 53 helps with routing requests from URLs to IPs or other URLs. So overall, Route 53 can use public domains, so you have to own them or buy them, and we'll see this in the next lecture, or private domains, and you can just create whatever domain you want, and these private domains will only be resolvable within your VPC, so within your instances. Whereas public domains, as the name indicates, they're public, so anyone can resolve them, such as google.com. So Route 53 will have advanced features, such as load balancing through DNS, and that's also called client-side load balancing, health checks, but they're quite limited, and routing policy. So there's simple routing policy, failover, geolocation, geoproximity, latency, and weighted. And honestly, I don't think you should know about them for this exam, but still know that basically you can route based on wherever your server are located in the world, or what is the closest with the minimal latency, or you can even perform a weighted balancing. So by basically saying, I want this amount of traffic to go to this instance and this other amount of traffic to go to that other instance. Overall, and that's quite popular, if you have an AWS resource and you want to build a CNAME for it, well, you don't do that. You actually use alias records because they're meant for AWS to be used better. And so it's performance reasons. So use alias records over CNAME for AWS resources. And we'll see this in the very next lecture as well. So overall, Route 53, I would say, is not much used in the certified developer exam. Still, I want you to know about it. So what I want you to know is all the record types. So A, quadruple A, CNAME, and alias, super important. And then you should know to use alias records over CNAME for AWS resources. So that's it for the overview. We'll just go into hands-on to see how in practice how it works, but that's it. See you in the next lecture. Okay, so as you remember, we have our auto-scaling group, and we have a load balancer. And so if I go to my load balancer, we basically get to our application servers. And so what we want to do is not have this crazy URL. We actually want a URL that's going to be nice for us. So for this, I'm going to my EC2 management console, and I go to services, and in the box, I type Route 53, and we get to the Route 53. So in there, we get this welcome screen because we haven't getting started yet, and we'll go to DNS management. So we'll get started with DNS management, and the first thing we have to do is to create a hosted zone. So to create a hosted zone, as you can click on it, you need to have a domain name and a comment and a type. And so as we actually don't have a domain name right now, first we have to do is register a domain. So let's go ahead and register a domain. So for this, you'll have to pay for it. So if you don't want to pay for anything, just look at me in this lecture. The domain names will cost money. So you click on register domain, and then you can choose a domain name. So you can choose a .com and .net, basically how much you want to pay, but I'll just use a .com, and I'll register stephantheteacher.com. So stephantheteacher.com, let's check if it's available. And it turns out it's available, so I'll add it to cart. As you can see, it is $12. Now I'll go ahead and continue. And now you have to fill in your information, so I'll just pause for this. And then my domain has been successfully registered, so stephantheteacher.com. And now it says you can wait up to 3 days to complete, but it usually doesn't take that long. So we go to domain, and now the domain registration is in progress. So I'll just have to wait a few minutes for it to be completed. So my domain is now registered, as we can see. And so if we go back to hosted zone, we can see that hosted zone was created for us automatically because we registered that domain through AWS. So I can click on stephantheteacher.com. And as you can see, we have 2 records already created here, NS and SOA. You don't need to know what they mean for the exam. This is fine. What we want to do now is create a record. So let's go back to our EC2 console, just so we can have a look. And under load balancers, we can see our load balancer, and this load balancer has a DNS name, this one, okay? And we see that it is a record. So this points to an IP, but we didn't know about it, and the browser worked just fine like this. Now I would like to just change that whole DNS name by stephantheteacher.com. So how do we do this? Well, we first have to go to create record sets, and now we have to choose a type. So even though we want to redirect a CNAME because we want to redirect a URL to another URL, and we could set up a CNAME, if we go back to the EC2 management console, we can see that the DNS name itself is a record. And so because I told you the best practice for Route 53 was to set up aliases record when dealing with AWS resources, the thing we have to do is choose a record, say it's an alias, and then for the target name, if we click on it, we can see our application load balancer right here. So by setting this up, we have stephantheteacher.com redirecting to, as an alias, a record to our load balancer. So we click on create. And after a second, we should see that stephantheteacher is now a record. The value of it is an alias to our load balancer, okay? So let's have a look and see if it worked. We go to stephantheteacher.com, press enter, and we get the hello world from the IP. So now we've basically used our own URL to redirect to this. The other thing I just wanted to show you, just for fun, it's not best practice, but what if we use the CNAME? So we'll say CNAME test.stephantheteacher.com, and the value of which will be this whole URL right here. So I'll say the value of my ELB, so I'll just set the whole thing right here. And it's not an alias this time, so we'll just say CNAME, and we'll click on create. Okay, so we're created. And so now, basically, if we go to the URL name cname test.stephantheteacher.com and press enter, right now it says the IP cannot be found, so we have to wait just a little bit for the whole thing to be resolved. And here it is now, the DNS request is resolved. And so here we go, we have also the hello world from the ELB that is working. And so what I want to show you is that through Route 53, we're able to set up all the records we need, A records, CNAME records, alias records, and also whatever you want, as all the records are available for you. But you just need to understand right here how Route 53 works, and then how they can be used to basically point to AWS resources and have URLs that are going to be much more friendly to use in the future. So I hope that was helpful, and I will see you in the next lecture. Now let's learn about the database service of AWS called RDS. RDS stands for Relational Database Service, and it's basically a managed database service so that your DB is managed by AWS, and you can use SQL or SQL as the query language. Basically, it allows you to create databases in the cloud and manage by AWS, so you don't have to do much. The databases you can create are Postgres, Oracle, MySQL, MariaDB, Oracle, Microsoft SQL Server, and Aurora. Aurora, you may have heard of it. It's basically AWS's proprietary database technology. Okay, we'll do a deep dive onto what that means. So why would you use RDS versus, I don't know, maybe deploying your own database on EC2 with maybe EBS? Well, it's a managed service, so you get a lot out of it. You get OS patching, you get continuous backup and restore and being able to restore to specific timestamps. You get monitoring dashboards, you get read replicas if you want to improve the read performance. You get multi-availability zone setups for disaster recovery. You get maintenance windows for upgrades, and you get scaling capability if you want to scale it vertically or horizontally. And the only drawback is that you can't really SSH into your RDS instances. You have to understand that Amazon manages them for you, so you don't interact with them directly. So honestly, I would not think about it twice. If I have to use a database on Amazon, I will use RDS. I will not set up my own database on EC2 because of all these good things we just saw right here. So what I want to do is just give you a little bit of deep dive into a few features, read replicas, multi-AZ, backup, etc., just to get a better understanding of how things work. So read replicas for read scalability is basically the idea. You have your application and you have your RDS DB instance. And this is how the writes and the read happen. So when you first set up RDS, this is what happens. You just have one application or multiple instances of your application and one database instance, and all the reads and all the writes go to there. But sometimes, after a while, maybe you realize that your application needs to read a lot from your database, and so you need to increase your read scalability. So what happens is that you can create read replicas. And using this feature, you can create up to 5 read replicas. These read replicas can be within the same availability zone, or cross availability zone, or cross region. So you can create an RDS instance replica right here, one right here. And it turns out that to replicate the data between the master instance and the replica instance, it is asynchronous. So asynchronous means that the reads will be eventually consistent. So that means that when you write to the master, there will be a small lag, a small latency, a small delay between when the write was happening in the master and when it will be replicated to the replicas. Okay, so this is something you should know. The replication is asynchronous. The replicas themselves really help with the read capability, so your application can now scale in reads. And the replicas, if you wanted to, could be promoted to their own database. It's a very quick and easy way to replicate a database and work with something on its own. The application now, something you should know, and it's sometimes asked in the exam, basically the application needs to change the connection string to leverage the read replicas. Okay, it's very important. Now, out of this setup, you'll get 3 connection strings, 1 for the master and 2 for the replicas. And so your application needs to be aware of it. So read replicas, if you remember, 2 things. It is multiple instances. Only one, the master takes the writes, all the other one takes the reads, and basically the replication is asynchronous. Okay? Now, this is something that you have to contrast with multi-AZ. And multi-AZ is for disaster recovery. So multi-AZ is basically your application still talks to the master database instance. Maybe it will be in availability zone A, and it'll do all the reads and the writes. And it turns out that this master DB will have this time a synchronous replication to one DB instance that is called the standby, hence the name S. And that instance will be in AZ-B, okay, or C or whatever you want. And so basically the idea is that only one DNS name will be exposed to your application, and that DNS name will have an automatic failover from the master to the standby in case there are any issues. And why would you do this? Well, it's to increase availability. So if a whole instance goes down, if a whole loss of an AZ go down, or network or instance or storage has a failure, basically our application can fail over from the master to the standby, and the standby will be promoted master, okay? And for this, there is no manual intervention that needs to happen in your applications. It will happen seamlessly. And so the only thing why you would use multi-AZ is for disaster recovery. As you can see, our application still reads and writes to only one database. And to make sure that you can fail over seamlessly, the replication is synchronous, okay? So this is not something you use for scaling. This is something you use for disaster recovery. So this is really the difference between the read replicas, which is used for read scaling, and the multi-AZ, which is used for disaster recovery. And you can use, obviously, a combination of both. Now, backups. Backups are automatically enabled in RDS. and they're automated backups. So there's a daily full snapshot of the database. So every night there will be a full snapshot of the database to make sure we know where it is. And then all the transaction logs are captured in real time, so that using that transaction log, you're able to restore to any point of time your database. And that's quite a nice feature. All these backups are retained for 7 days, but you can increase this to 35 days. And that's all for it for the automated backups. And so this is just enabled for you. You don't have to set up anything. And the really good thing about it is that you're able to roll back to, say, 2 p.m. yesterday very, very quickly, and being able to, save your applications in case of problems. Now you can also trigger manual database snapshots, and they're manually triggered by the user, and the retention is for as long as you want. So you would do this if you need to know that there is a state, a very, very particular state that you need to save, or you want a long-term backup for whatever reason. You would use database snapshots. Now on the security side, super important, and that's, the exam really loves security, so you need to be aware of all the security stuff. So the encryption is at rest, and again, we see KMS being mentioned. So there's encryption rest capability. You have to enable it using KMS, and it'll give you the AES 256 encryption. You can also use SSL certificates to encrypt data to RDS in flight. Okay, so that's the contrast. At rest means on disk, in flight means over the network. And so to enforce SSL, and that's quite a popular question, for Postgres, there's one parameter we can set in the RDS console in parameters group, and it's called RDS.force_SSL equals 1. That's for PostgreSQL. And for MySQL, within the database, you have to run this statement. And it's quite a complicated statement. But what you notice is that at the end, it says require SSL. So that's to enforce SSL. Once you run this statement, basically no user will be able to connect to MySQL unless on SSL connection. And so that's quite a popular question. Now, if you want to connect using SSL, how do you do it? Well, you provide the SSL Trust certificate that you can download from the AWS website. And then you provide the SSL option when you connect to your database. And that's about it. It's quite simple. But you need to know the difference between enforcing SSL and connecting using SSL, okay? Connecting using SSL doesn't mean that SSL is necessarily enforced. So knowing how to enforce SSL is something you should know and make note of. Now for security, RDS databases are usually deployed within a private subnet so that you don't expose them publicly. And RDS security works by leveraging security groups, as we'll see. So basically, security groups allow to understand who, like which IP or which other security group can communicate with RDS. In terms of who can manage RDS, for this we'll use IAM policy. And for connecting and logging into the RDS database, so actually making operations within the RDS database, we'll use traditional username and password, or you can also integrate it with IAM users. This is new for MySQL or Aurora, okay? Something you should know about. Now, talking about Aurora, just a last bit you should know about RDS. Aurora is basically a proprietary technology from AWS, and it's not open source, so we don't know how it works. But basically, Aurora is compatible with Postgres and MySQL. So they're both supported. And the idea with Aurora is that it's cloud optimized. And so Amazon claims there is a 5x performance improvement over MySQL or a 3x performance improvement over Postgres. And it comes with like incremental storage. So you can increment the storage over time from 10 gigabytes up to 64 terabytes. It can have 15 replicas with MySQL. And you can do replication faster, like it says sub 10 millisecond replica lag. And also there's failover, so it's multi-AZ by default. It's high availability native, so your application will failover directly. And although Aurora costs more than RDS, a bit more, it's said to be more efficient, and so overall your cost should decrease. With this Aurora database, basically Amazon is trying to push a technology that is going to be a bit less painful to set up, a bit more scalable, and a bit more cloud friendly. So there's not that many questions about Aurora in the exam yet, but you should still know about it. And what's the difference between RDS and Aurora? Aurora is going to be a proprietary technology from AWS, comes with a lot of goodies. Whereas if you want to set up Postgres or MySQL and RDS, then you have to set up the read replica and the multi-AZ as options if you wanted to. Okay, so that's all for RDS. In the next lecture, we'll go ahead with the labs. Okay, so let's go ahead and play with RDS. So I'm going to go to the RDS service and we are going to create our first database in RDS. So we'll go to the databases tab and we'll click on create database. Now we are getting into this new interface and we need to create a database. Now we have the standard create or the easy create. Obviously we want to learn how RDS works, so we'll not go into the easy create because this will set up everything for us. We want to know all the options and understand how we can tune them one by one. So we'll go into the standard create. Now, as we scroll down, we can see we have 6 different engine types at the moment. We have Amazon Aurora, MySQL, MariaDB, PostgreSQL, Oracle, and Microsoft SQL Server. So if you want to use the free tier with RDS, Aurora does not work. Aurora is the new kind of offering by AWS for databases, and it is not compatible with the free tier. So we'll not use Aurora. In this lecture, we'll be using MySQL because it is free tier compatible. You could also use PostgreSQL if you wanted to, but for this hands-on, it will be MySQL. So we'll use MySQL Community, and we'll use a recent version, for example, 5.7.22. I'll scroll down, and then we can have templates. So do we want it to be ready for production, dev test, or free tier? So obviously we want to remain within the free tier, so I'll click on free tier, and this will come with a few values already set up for us. But we'll still go ahead and scroll down and see what we can do with it. So first, we need to name our database, which is a database instance identifier, and this needs to be unique across your region. So I'll just call it my first MySQL. Then we need to specify credentials for the master username. So in this case, I'll choose Stefan, and then for the master password, I'll choose something very simple, for example, password, and I'll enter the password again. So this is for the master logging in your database, and it will have admin power in it. Now we need to scroll down and look at the DB instance size. So because we are in the free tier, we want to only have the option to do a TB T2 micro. So all the other options are grayed out for the very reason that we have specified that we wanted free tier. So it's a safety. But if you click on dev test or production, then you would have access to all the different kind of instances in here. We can choose standard class or memory optimized and more. So in this case though, we'll continue with DB T2 micro, which has 1 vCPU and 1 GB of RAM. Then we need to learn about how much storage we want for our database. In our case, we want SSD storage and 20 GB. This is something that is available only for free tier, so it can be up to 20. And sometimes you get this really weird UI quirks. So if you get this, just increase to 21 and back to 20 and it will be fixed. Okay, now for the storage autoscaling, we can enable storage autoscaling. That means that if we keep on writing to our database and we reach this 20 GB of storage, it will automatically increase it for us. So we don't have to do it for now, but I will disable it and we'll go right back to 20. Okay. Now for the availability and durability, what do? Do we want to have multi-AZ? So multi-AZ, as we saw, is a way to have a standby database instance ready for use in case an availability zone goes down. And so this is something we definitely want in production, but this is not something that's available for us when we do the free tier. Therefore, this option is disabled. But if we wanted to have production and wanted to make sure that one AZ could go down and we could still use our database, definitely using multi-AZ deployment would be the way to go. Now for connectivity, you launch your database in a VPC or virtual private cloud. And so as such, we'll use the default VPC that has been created for us when we created our account to launch our database. We can specify additional connectivity configuration. And one that's very important is whether or not we want this database to be publicly accessible. So in most cases, you will not want your database to be accessible publicly because you just want it to be available within your virtual private cloud or VPC. But because we want to connect in this hands-on to our database just to show that it works, we'll use yes, and we'll allow connections to our database directly from our machine. Now for security group, we can choose an existing security group or create a new one that will be directly created for us for this database. So I'll just enter my first RDS as security group, SG. And then where do we want this database to be created? No preference, but we could choose it in EU West 1, 3A, 3B, or 3C. Okay, finally the database port is the standard port for MySQL, which is 3306. We'll scroll down and we can look at the additional configuration. So the initial database name will have MyDB. This way will be automatically created by RDS. The parameter group we don't touch right now. We could have IAM DB authentication. So that means that we could connect to our database directly using IAM users and roles, but we won't enable it right now. We just need to remember that it is an option. For now, we'll just connect to our database using the standard username and password that we have created from before. But it's good to know that it's an option. And then do we want to have backups? Yes, we want to have automatic backups. And how much do we want to retain these backups for? 7 days all the way to 35 days. So I'll just keep it as 7 days. the backup window. So do we want to specify a specific window of time when we want RDS to perform our backups, or do we have no preference? I'll just keep no preference. Then finally, do we want enhanced monitoring to get more metrics, such as number of threads and so on. Log exports, if we wanted to export the logs into a service called Amazon CloudWatch Logs. And the IAM role to do all this stuff. We won't need to specify it. We only need to do it if we had ticked one of these boxes. We'll scroll down. Do we want to enable auto minor version upgrades? Does it mean because RDS is a managed service, we definitely want it to automatically upgrade our database for minor versions automatically, and they will happen during the maintenance windows of the database. And for the maintenance window, what preference do we have? Do we want to have a specific day, start time, and duration, or do we have no preference? Finally, last one, and we're all good to go, we'll have deletion protection. And if we click on this, that means that we won't be able to delete our database without removing first the deletion protection. So I'll leave this unticked for now. So here we go. We see that this RDS is within the free tier. We get T2 micro instance, so this is good. It's what we have. Single AZ, it's not multi-AZ. 20 GB of SSD, and 20 GB of automatic backup storage, and so on. So we'll click on Create Database, and here we go. The database should be created, and this may take a few minutes to launch, so I'll be right back. By clicking on the database right here, I'll be right back when this is done. So while my instance is still being created, I want to show you a little SQL program I like, which is called SQL Electron. And SQL Electron is basically a DB client for your database. And so it works for Linux, Macs, and Windows. That's why I like it. And it gives you a GUI, so a graphical user interface, to connect to your database. So I invite you to download the GUI and then install it on your computer. Basically, you go onto this GitHub page, and here, if you're on Mac, you use the DMG. If you're on Windows, you use the Win package. And if you're on Linux, you can use the SH package or the Debian and RPM. So once you download it and install it, after this, my SQL Electron is installed, and I click Add. And here I can add a connection. So I can connect to my RDS database, and just a name for it. And I created a MySQL database. Now I need to put the server address, the port, and so on. So for this, we can go back to our page, and now we can see that the instance is backing up, so it's been created. And if we scroll down, all the way down, we can see a connect block with the endpoint. And the endpoint is basically the URL I need to use to connect to my database, and the port is 3306. And it's publicly accessible, so I should be able to access it from within my computer. So let's hope for this. I copy this and put the server address right here, and then the username is going to be Stefan, and the password is going to be password. So that looks good. Now we would be able to enable SSL if we wanted to be having a secure connection, but for now we're good. So we'll just click on test, and the connection test that is successfully connected. Happy days. I save it, and I connect to my database, and here I am in my database. And we can see that there's MyDB on the left-hand side. This is the database that was created first for us. You don't need to be a SQL expert to use MySQL or database, but this is not a course about SQL anyway. So as soon as we're connected, we know everything worked, and that's about it for the hands-on. Okay, what you should know about is that all the connections and options you had when creating this RDS database, the fact that there's a security group that was created for your instance, and you can click on it to go and see the details of your security group. So we can see that it authorizes my IP on the port 3306, which is good. And you can see all the network and security configuration, if you have backup, if you're multi-AZ, etc., etc. So this is quite nice. The last thing you can do is do instance actions. And as you can see on the right-hand side, we could stop it, reboot it, and create a read replica. So if we wanted to create a read replica, we could just click here and have a second database that we can connect to just for reads. We can also take a snapshot to basically take a backup on ourselves, and then restore to point in time using the backups, and migrate a snapshot if you wanted to move the snapshot away into another region. So I hope that was helpful. That was a quick overview of RDS, but we're able to create a database, MySQL, connect to it using SQL Electron, and basically this is a database that's available for our applications to be used if they need to have one. Okay, so that was it. Hope you enjoyed it, and I will see you in the next lecture. Now we're getting an AWS ElastiCache overview. So the same way RDS is to get a managed relational database, ElastiCache is to get a managed cache, in this case Redis or memcached. And caches are basically in-memory databases, so they run on RAM, and they have really high performance and usually really low latency. And their role is to help reduce the load off of databases by caching data, so that the read-intensive workloads read from the cache instead of reading from the database. So basically, it also helps make a bunch of applications stateless by storing states in a common cache. And it has a write scaling capability using sharding. It has a read scaling capability using read replicas. It has multi-AZ capability with failover, so just like RDS. And it has AWS taking care of OS maintenance, patching, optimization, setup, configuration, monitoring, failure recovery, and backups. So basically, it looks a lot like RDS, and there's a very good reason. It is pretty much the exact same thing. It's an RDS for caches, and it's called ElastiCache. Okay, that's what you should remember. So there is write scaling, read scaling, and multi-AZ. Now, you may be asking, how does it fit into my solution architecture? And at first I was troubled too, and really this diagram that I created really helps put things into perspective. So when we have our application, it communicates to RDS, as we've seen from before, but we're also going to include an ElastiCache. And so our application will basically first query ElastiCache. And if what we query for is not available, then we'll get it from RDS and store it in ElastiCache. So that's called a cache hit when you get into ElastiCache and it works. So we have an application, it has a cache hit, and we get the data straight from ElastiCache. In that case, the retrieval was super quick, super fast, and RDS did not see a thing. But sometimes our application requests data and it doesn't exist. This way, it's a cache miss. So when we get a cache miss, what needs to happen? Well, our application needs to go ahead and query the database directly. So we'll go ahead and query the DB, and RDS will give us the answer. And our application should be programmed such as it writes back to the cache the results in ElastiCache. And the idea is that if another application or the same application will ask for the same query, well, this time it will be a cache hit. And so that's what a cache does, it just caches data. So the caches will help relieve the load in RDS, usually the read load, definitely. And the cache must also come with an invalidation strategy, but that's up to your application to think about it, so that only the most current data and most relevant data is in your cache. Now, another solution architecture you must have is user session store. And so in this case, our user basically logs into our application, and our application is stateless, so that means there's a bunch of applications running. Maybe they're running into an auto-scaling group, and so all of them need to know that the user is logged in. So the process is such: the user logs into one of the application, and then the application will write the session data into ElastiCache. So this is it. The application, the first one, just wrote the session data into ElastiCache. Now, if the user hits another instance of our application, okay, in our auto-scaling group, for example, then that application needs to know that our user is logged in. And for this, it's going to retrieve the session off of Amazon ElastiCache and say, oh yes, it exists, so the user is logged in. And basically, all the instances can retrieve this data and make sure the user doesn't have to re-authenticate every time. So that's basically another very common solution architecture and pattern with ElastiCache. It is basically, number one, to relieve load of a database, and number two, to share some state, such as the user session store, into a common ground, such as all the applications can be stateless and retrieve and write these sessions in real time. So as I said, ElastiCache can be basically two technologies. It can be Redis or Memcached. And so Redis is definitely going to be the most popular. It is an in-memory key value store, and it is super low latency. So we're talking sub-millisecond, so less than a millisecond latency. The cache can survive the reboots by default. It's called persistence. So not only it's a cache, but if the cache reboots, you don't lose your data, and that's pretty amazing. It's great to host user sessions, as we've seen before. Also leaderboard for gaming, because there's a sorting capability. Distributed states, so again, the user session is a good one. Relief pressure of databases, such as RDS, and we saw this in the architecture slide. It also has a pub/sub capability for messaging if you want to implement pub/sub. And obviously, it comes with all the goodies that Amazon gives us, which has multi-AZ with automated failover for disaster recovery if we don't lose the cache data, and support for read replicas. So it's really good for you to know that there is this capability not to lose the data if you have reboots. It's called persistence, and also with a multi-AZ, you can survive service outages. Now, Memcached is a bit less popular, but still available. It's an in-memory object store, and the cache this time doesn't survive the reboots, and the use case are to do a quick retrieval of objects from memory and to cache often access objects. To be honest, and I did my bunch of research, Redis is now largely growing in popularity. It is the dominant cache technology. has a better feature set than Memcached, and overall is going to be the #1 choice. But Amazon still called ElastiCache. So personally speaking, if I need to do caching, I will use Redis and not Memcached. But that's a personal preference. The AWS exam will never ask you if Redis or Memcached is better or a better fit. Just know that ElastiCache in general is a cache, and just know about the use cases, okay? This was just me giving you a small insight into the technology you should use. So that's it for ElastiCache. I hope that helps, and in the next lecture, we'll just go ahead and quickly go through the setup of ElastiCache just to see how it works. So in my console, I will type ElastiCache, and we get the in-memory cache. By the way, cache or cache, I never know, but I'll just say both, okay? So ElastiCache, when you get started, you click on Get Started Now, and then you'll be able to choose the cluster engine. So we have Redis or Memcached, and as you can see, if we use Redis, we can have a cluster mode enabled, which is basically allowing us to have more persistence and more robustness. And as you can see here, ElastiCache for Redis offers multi-AZ with auto failover and enhanced robustness. So it really seems that Amazon also is pushing for Redis to be used in this case. Okay. So now I will untick the cluster mode because we don't need it right now. So I'll just use plain Redis, and I'll just name it my Redis and my first Redis instance. And then the engine version compatibility, I'll choose 4.0. The port is 6379, that's the standard port for Redis. We can also set up some parameters, so this is fine. Now the cache size, I will not use R4 large, otherwise I'm going to build a lot of money. So I'll just use a cache T2 micro just to get started, just to make sure we have this. And then we can set up read replicas, as I said from before, but I will set up no read replicas because otherwise I'm going to pay a lot of money for this. So, but just so you know, there is the capability of setting up a cluster and having read replicas and being able to fail over for availability. So the subnet group, we have to create a new one and just name it whatever you want. So my subnet group is a great one. So my Redis subnet group is a great one. So it's my Redis subnet group. And it's basically saying in which availability zone would you like to launch your Redis. So I'll just choose one because we only have one instance. So EUS 3A. And then that's good enough for me. Now we need to attach a security group, so we can attach the default security group that comes with it, which works great. And now we have option to set up more security, so we can use encryption at rest. So it's a good capability to know. We can encrypt ElastiCache at rest, and we can also have encryption in transit using SSL. So if we tick these two, basically they work great, and we can click on info to understand how they work. It's just a tick box away. So I will disable them for now, but just so you know, there is basically security in every AWS component. We don't need to import it as a cluster. We can enable automatic backup, so it's quite a good option. And we don't need a maintenance window, and we don't need notifications right now. So we click on create, and that was just that simple. Now we just need to wait a bit, and our Redis cluster is being created. And overall, we should have a good time playing with Redis if your application knows how to use Redis as its logic. So that's it really. As you can see, then you could navigate the left menu, but as far as the exam goes, really it's all about knowing how to launch a Redis, knowing about the capability, the security, the read replicas, the clustering, a bit knowing about Redis, and that's all really. So this is enough for the hands-on, very, very high level, but we've been able to create a Redis cluster with one machine in it, and that was it. Hope you enjoyed it, and I will see you in the next lecture. So now we've seen that ElastiCache is a cache. There are two main strategies that you need to be aware of when dealing with cache patterns. So ElastiCache, first of all, we remember it is very helpful if you have a read-heavy application workload, so an application that reads a lot. So we're talking about social networks, gaming, media sharing, Q&A portals, where most of the requests are going to be read requests instead of write requests. And it's going to be really helpful as well if you have a compute-intensive workload, for example, a recommendation engine, and you want to save or cache the results of these computations in order not to compute them every single time. So two main use cases for ElastiCache. Now, how do you put data into ElastiCache? That's the question, right? First of all, you need to write some code. It's not magical. You need to write some code. It's not automatic. There's no direct integration between ElastiCache and RDS. And then you need to implement a pattern or a caching strategy for ElastiCache. So there's two I want to discuss today. There is lazy loading and there is write through. And based on the kind of applications you have, you're not going to use lazy loading, or maybe you're not going to use write through, or maybe you'll use them both together. It just depends on how you feel about your code. So let's talk about lazy loading. Lazy loading means that you load the data only when necessary, hence the name lazy loading. So let's take our application, and there's a database, for example, Amazon RDS, and we have implemented a caching layer, ElastiCache. Now we need to change our application code to do the following. First of all, it will always look when there's a read request into ElastiCache, first type. So if there's a cache hit, perfect. We have a very low latency request, the data is saved in ElastiCache, and we can return it right away to our users. But in case there is a cache miss, that means that ElastiCache doesn't return any data to us, it returns null, I haven't found this key. Then our application must do a read from the database. So it needs to start querying the database. The database will come back with the information that we want. And then our application will write that data to the cache and then return it to our user. So as we can see here, in case we have a cache miss, we have 3 requests that need to happen before our application can send data back to our user. So when we use lazy loading and what's the pros? Well, only the requested data is cached. The cache is not going to be filled with unused data. So this is quite interesting because if some data is requested, it will be in the cache. So it's a good pattern. The cache won't be fully utilized, or there won't be too much bad data in there. And in case the cache disappears, a node fails on ElastiCache, it's not fatal because we can just respin an ElastiCache instance and the cache will just be warmed up. So that means there will be more reads from the DB, but overall we haven't lost any data. So the cons to this method is that in case there's a cache miss, as we said, there is 3 round trips that happen. So the penalty is quite big and it may be a noticeable delay for your users for that one request to read. And usually users are pretty picky about reading data from your web application. Also, in case the data in your database gets updated in the database, it's not necessarily going to be written back into ElastiCache. So there's a chance that users will see stale data. So the way to maybe deal with this is to implement a TTL, or time to live, to say to ElastiCache that after 5 minutes, any kind of data point should go away. And so that guarantees that the maximum amount of time some data will be stale will be 5 minutes. So that's lazy loading. First strategy, quite easy to understand. The second one is write through, which is to add or update the cache whenever the database is updated. So we have the same, our application, RDS, and ElastiCache. And so again, when everything is great, we get a cache hit, but that's for reads. When it goes to writes, this time we're going to write to the database first, and then we're going to write to the cache. So here, there is most likely not going to be any cache miss because every time we write to the database, we're going to also write to the cache. So the pros of this is that the data in the cache is never stale. Anytime we write to the database, we should be writing to the cache, and so our database and the cache should be synchronized in some way. There's going to be now a write penalty. Before we had a read penalty in the lazy loading, but now every time we do a write, we have 2 calls that are being made, one to RDS and one to ElastiCache. But from a user perspective, you humans expect a small delay when we write data, and we expect less delay when we read data. So it could be fine to have 2 writes happening for each, 2 calls happening for each write. Now the cons of this is that the data will be missing in ElastiCache until it is added or updated in the database. So a way to mitigate this is to also implement the lazy loading strategy as well, meaning that if we get a cache miss, then we're going to look up in Amazon RDS and fill back the data into ElastiCache. So it is possible to combine the write through and the lazy loading method. Finally, your cache is going to have a lot of data that's going to be useless or unused, and so a lot of data will never be read. So that means that your cache must be pretty big as your database, I would say, but there is a chance that it will be churning. That means that a lot of data will never be read. So that's it for these 2 strategies. Hopefully that was clear enough. You can combine them too, but hopefully you understand the pros and cons, write penalty versus read penalty, the kind of round trips that happen. You need to know these 2 concepts going into the exam. All right, that's it. I hope you liked it, and I will see you in the next lecture. Okay, so now finally the AWS VPC. So within the region, you're able to create VPC, Virtual Private Cloud. And when you first created your account, there was a default VPC. Now each VPC contains subnets, and subnets are just networks. And each subnet must be mapped to an AZ. So basically, if we take a look at this VPC, we have 2 subnets in AP Southeast 2A. We have a public subnet and a private subnet. So it's very common to have a public subnet in your AZ, and it's very common to have a private subnet in your AZ. Basically, the difference is that the public subnet is accessible from the World Wide Web, whereas the private subnet isn't. it's also common to have as many subnets per AZ, and overall many subnets overall in your VPC. So this is a typical architecture you get for VPC. So in this case, we have a VPC. It has 6 subnets, 3 public ones, 3 private ones, and each of them are in AZ. AP Southeast 2A, 2B, and 2C each have 2 subnets. Fairly simple, just remember about it. So remember in our course, basically everything came with default VPC, and there was 3 default subnets available for us. Now the public subnets, what do you put there usually? You put there your load balancers, your static websites, your files, your authentication layers, and the private subnets, usually they will contain the web application servers, your databases, and so on. So basically you ask yourself the question, what do I need to reach from my browser over the public internet versus what do I need to reach from my private network, or what does I need to be reached from the web actually? And so for example, our web application servers, as we've seen from our course, they are behind the load balancer. So they don't need to be in the public subnet, they can be in the private subnet and talk directly to the load balancer only. So basically the idea is that, as I said, the public and the private subnets, they're able to talk together and they're in the same VPC, and this is how you just separate your concerns. So just a quick brain dump on the VPC. Overall, I would say they're not asked much at the developer associate exam, okay? But still, my conscience needs to be clear, and I need to teach you about it a little bit just so you're aware of what they are at a high level. All new accounts come with the default VPC, and it's possible to use a VPN connection to connect to your VPC, and basically that gives you access to all the private IPs straight from your laptop. There's something called VPC flow logs, which allow you to monitor the traffic within, in and out of your VPC, which can be quite useful for security, performance, and audit. And the VPC are going to be at the level of the account per region. So if you have 5 regions, you need to have 5 different VPC. And if you have 5 accounts, again, all the VPCs are going to be different. The subnets are only within the VPC, and the subnets are attached to one AZ only. Some AWS resources are able to be deployed in VPC, while others cannot be deployed in VPC, and that's just how AWS works. And overall, a very good feature to know is that you can peer VPC, so within your own account or across accounts, to make it look like they're part of the same network, and that's quite a common pattern. Basically, when you start to have a large organization and many different accounts, but you want to make sure all the VPCs seems like they're part of the same network, you would go ahead and peer VPCs. So the only reason I'm telling you about VPC is so that we can look at the typical architecture of a web app, which is called the 3-tier architecture. And this is, to me, this is the achievement of this whole first 2 sections on the fundamentals of AWS, is that with all the building blocks we have, we're actually able to create something quite complicated, but quite secure at the same time that makes sense. And this is all that we've learned into one slide. So if you understand this slide, to me, you have understood everything I've told you about. So we have the user on the left-hand side, and it will query route 53 for an alias record. And using that alias record, it will go straight to our Elastic Load Balancer, okay? And that Elastic Load Balancing is in the public subnet because it has to be accessible from my machines, for example, or from the World Wide Web, right? Behind the ELB, we have an auto-scaling group. And the auto-scaling group, because we need it to be highly available, is going to be split between, for example, 2 AZ, AZA and AZB. And the auto-scaling groups basically spins up EC2 instances. In our case, these are M3 instances in EC2, and we have 4 of them, 2 in each AZ. And the Elastic Load Balancer basically spreads out the load onto each of them. But these instances obviously can be added as scale out or removed as scale in, and that really allows our ASG to be responding to high traffic or low traffic. Now, our instances, they usually talk directly to our RDS database to do some operations. And so we have RDS master right here. And because we want to be super resilient to failures, we also set up cross AZ replication to have a standby replica, RDS slave, basically a standby. And basically if the first RDS database fails, our application automatically fell over to RDS. But because we're very conscious about reads and writes and user sessions, etc., we also wanted to set up an ElastiCache cluster, so it could be Redis in this case, and this will basically allow us to read stuff off the cache and cache data, for example, user sessions or data straight from RDS. And so that's the typical architecture. As we can see, finally, the auto-scaling group is in the private subnet because it only talks to the ELB, and then our ElastiCache and RDS, they're in the data/private subnet. So you can create another subnet tier called the data subnets, or you can just reuse the private subnets. But basically, all these things right here are not directly accessed by me. As an end user, I only access my Elastic Load Balancer. So to me, again, if you understand what I'm saying here, and if this makes a lot of sense to you, then you've understood the fundamentals of AWS, and I want to congratulate you for it. And thankfully, we're here. So in the next lectures, in the next sections, we'll go a deeper dive and we'll start exploring serverless concepts and CI/CD and more developer workflows. But when you start with AWS, you need to be able to look at this diagram and say, yep, that makes a lot of sense before we go into the more advanced concepts. So hope you enjoyed it. Hope you understood everything so far, and I will see you in the next lecture.